Hello and welcome to the OMNEX webinar, AIAG VDA FEMA webinar number 2, focusing on PFMEA. Today's webinar is being presented by Chad Keimel, the CTO of OMNEX, and Greg Gruska of OMNEX. Chad Keimel is the CTO and founder of OMNEX. He graduated from the General Motors Institute. After General Motors, he founded OMNEX. Chad is also the president of OMNEX Systems, a software provider for ISO 9001, 14001, 27001, and many other risk tools such as FEMA and control plans. Chad is the author of 7 books and more than 100 papers, including several on integrated management systems. The other presenter today is Greg Gruska. Greg is the OMNEX champion for APQP, PPAP, FEMA, ISO 26262, Lean Six Sigma, and is a fellow of the American Society for Quality. Greg is an active writing member of the MSA, SPC, FEMA, and eFEMA manual subcommittees for the American Automotive Industry Supplier Quality Requirements Task Force. During this webinar, if you have any questions, please enter them into the questions dialog box in your GoToWebinar panel, and Chad and Greg will get to them at the end of the webinar. A recording of the webinar will be provided to all attendees after the webinar is completed. Take it away, Chad and Greg.
Miles, thank you very much. Welcome back, folks. Thank you for signing back in today. We did not want to wait very long. In fact, we wanted to immediately, since many of you have been waiting for the second webinar following the DFMEA. So let me just tell you a little bit about the different roles. I know we were introduced, but let me just say this, that if you go back in sort of FMEA history, maybe the credit I can take is for coming up with the linkages between process flow, FEMA, control plan, and work instructions back in the 1980s. And also sort of being the, what is the right word I'm looking for, the innovator behind a software package called Aqua. Along with me, we have Mr. Greg Gruska, who is the author of the 4th edition, or one of the authors who's on the writing committee of the 4th edition. And so what we'd like to do today is to offer our thoughts on the AIAG VDA PFMEA. And let's start. Let me go right to the agenda here. So what we'll do is we'll little bit, for those of you who are part of the DFMEA, we'll repeat some things, but there's also some different things here for the PFMEA, the background. Next, what we'll do is introduction to the new form, how it works. We'll go through the 6-step process. We'll talk about the PFMEA in action, conclusions and recommendations, and as time permits, we'll have a panel discussion among ourselves. But I'll just for those of you joining in, Greg and I spent an hour trying to reduce the slides yesterday. So there's a good feeling that we probably will go right to the hour. But we will stay back for Q&A, so expect the Q&A to take a little bit more time beyond that. So the new PFMEA and the first look at the new PFMEA. Folks, I'll just say this, and hopefully I'll tell you this also in the end of the webinar, that we are going to do a 3rd final webinar in about a few weeks. And in the final webinar, what we'll do is we'll give you our critical thoughts in terms of the handbook and generally what we see as what we are working with many different companies as we speak today, implementing it, not just in automotive. We have an opportunity actually to help implement it in multiple different industries. What do we think a critical analysis of the new AIAG VDA, DFMEA, and PFMEA? With that, As you well know, it's been a couple of years where the VDA and AIAG work together. I probably mentioned that to you last time, but let me just tell you, since we have a very strong VDA team in our German office, this is something Omnex has been also trying to do simultaneously. So this is why we have some real strong feelings in terms of both the VDA and AIAG approaches, and we have given a couple of conferences in Germany our thoughts in terms of the VDA and AIAG. Why combine it? Well, in the end of the day, many of our large multinational customers, have had a whole group doing VDA and a whole group, of course, the U.S. contingent and probably the rest of the world doing AIAG formats, and they really, once you get to understand them, they're not as compatible as one would think. So resulting in non-value added approaches, where there are two different approaches. So this is a much needed handbook integrating the two. We're currently undergoing a 90-day commenting period. As Greg mentioned yesterday, maybe yesterday was the last day or the day before yesterday was the last day. So if you haven't given your comments, please do check and see if there's still time to do that. We don't expect the draft to be released in March. We do expect it to be released sometime past March, after they've had a chance. I think it's going to take some time. So April, May, June, July, expect final first edition to come out. And for those of you in the sort of midst of this IATF 16949 transition, rest assured you won't be asked to do any of that till the very end of the year. But I just want to also just say, some of our customers are already talking to us, and we're doing sort of overview and on-site training classes for some of our customers in both the DFMEA and the PFMEA, looking at how this first edition will work for them. All right. So if you look at this, and actually, unless you zoom in, let me try that, folks, you won't really see that. So you can see there, instead of the design functions, you're seeing process item, process step, and process work elements. What can we tell you? Well, that the first three rows, and the first three columns, and what we mean by that is that this column, structure analysis, function analysis, and failure analysis, just like the DFMEA, are paired in threes, and they are related to each other. We'll explain that a little bit more in the next slide. Other than that, very much the forms are very similar, and they work in the same way. Okay. And as we said before, one clearly noticeable is that there's a lot more columns in this version than the previous version. So, Greg, maybe you can talk a little bit about the way this form views and segue right after that into the 4th edition form.
No, we don't have the 4th edition form.
Okay.
This is trying to walk through the form that's in the handbook and associated with the same type of activities that are in the 4th edition. So the first three talk about what is the scope, what is the structure of the activities that you're going to be doing. So if your scope is what is the extent of the analysis, and the structure deals with how does it look, what is the elements in it. That is followed by what are the functions and requirements. This is a little bit more detailed than the fourth edition because we not only want to know what are the functions of our focused element, which is the process steps, but also the process item and the work elements. The third section talks about what can go wrong. In the fourth edition, this was just the failure mode analysis, but in this case, we look at what can go wrong on all the functions that we've had identified, whether it's at the higher level, at the focus level, or the lower level. So we do more pre-work on this. Now, once we identified what can go wrong, we can then associate the failure mode with the causes. The causes are the failure modes at the work element level, the lower level, and the effect, which is the impact to the customer at the higher level, the failure modes at the higher level. Once we do this, we come up with what is called the failure net. We ask how this can be prevented, specifically how can the causes be prevented, and then how can the causes be detected. Once we have all these, we want to know what is the risk. To do the risk, we have to identify how bad is it, severity, how does this occurrence, and how effective is the detection. Once we do that, we come up with the action priority and determine how can this be improved. So the logic going through is the same whether you do the fourth edition or the handbook. The difference is the amount of pre-work that needs to be done and the sequence in which it needs to be done.
Thank you, Greg. So as you can see, I'll just make this comment. For those of you who know PFMEAs and have been doing PFMEAs for a long time, don't fret. Really, it's not all that different. All right, some terminology difference, and we can hopefully clarify it even in this short presentation. So if you look at this 6-step process being used in the PFMEA, it is the very same as the DFMEA. We'll just say this, the structure analysis and function analysis, which is very important, the DFMEA, maybe are not as important when we do the PFMEA. Well, more on that later. So the first step, of course, is a scoping step. And if you look at the scoping step, they talk about the 5 T's. Yes, there needs to be a scope, but if the scope means when a new product or process is being introduced, you don't work on all the processes in the line, that you scope it down, works very counter to the US philosophy practice since the DCP days. I may have not mentioned, Greg was the, worked with Ford Motor Company when the DCP came out. Greg, what is the book that started everything off that you had written? What is the title of the book?
CP Squared, Comprehensive Process Control Planning.
Right. And that was like early 1980s.
Yes, yeah, it was.
Because the DCP came out, I don't know, in the mid-80s. It's the same time Omnex was working very hard because of Q101 in terms of the first 2 questions being on FEMAs and control plans. So what has brought us to where we are today, which in terms of very low PPM, is really that we work on all processes. And in fact, the 4th edition mentions all the way from receiving all the way to shipping. And there are several CSRs that talks about additional ensuring that even inspection is taken into consideration when you do FMEAs. All right. So we just want to make a point here that there's a scoping. yes, you do need to identify what the project is all about, but generally, when you do, scoping, let it not be the idea that you're not going to do all the processes. And number two, which is the, if you look at the early, control plans and FEMAs, there was a focus on special characteristics only, or as Ford would call it, critical and significant, and GM would call it KPC, KCCs. And the DCP introduced the idea to work on all characteristics, and you have seen many thoughts along those lines first in the ISO TS 16949 and then in the IATF 16949, that all process controls need to be in the control plan. Similarly, we think about all the characteristics being addressed in the FEMA. All right, having said that, here is the example you see in the handbook for the scoping. And what you see, let me just, here, in terms of the assembly is just this blown up, so you see a little bit more of it. This is actually step 2, the structure analysis, but they're also showing sort of the process flow if you want to think about it, the work cell, with this circle that this job, this FMEA, this is going to focus only on these 2 processes. All right, let's move on. Folks, we're going to do a running example of hang on one second while I try to change this pointer.
Don't worry.
Maybe I can't. Of the 5 T's, and we're going to take the example of, folks, hang on one second here. Well, that was actually easy. So let me, we're going to do a running example. This actually is what, will be done in the Omnex software Aqua Pro. One of the things the handbook talks about is the need for software for complex projects. And we wanted to use this as a way to show you how something like that could be. So let me just pause it here and then zoom in. And, the scoping could be as simple as the 5 T's filling in. And what you could also do is the option of filling it in and having it go right to the header of the FEMA. All right, oops. Step 2. Step 2 is a structure analysis, which is unique to the AIAG VDA, PFMEA, and DFMEA. What is the structure in a PFMEA? We knew the structure in a DFMEA was the BOM. So to keep the same steps, you see the structure analysis here with 3 levels. What is the higher level? The higher level is the overall line or work cell. The focus level is the process steps, and the lower level is the idea of what they call the work element. So hopefully some of these terms can become common as we use it throughout this presentation. Sometimes I might also, let me go back to my pointer. Let me pick my laser pointer there. You see this word 4M? It's actually what we used to call 5M1E, man, method, material, and so on, okay? And the 1E was environment, and then...
So we called it milieu for environment.
Yeah. So, milieu, right? Anyways, it must be a German term. When you see 4M, think 5M1E. We also added the idea of reuse because this is something very important in terms of what Omnex sees as a strategy for both DFME and PFMEA. When you're doing the process steps, you can use existing best-in-class processes along with the failure modes, the controls, and the work instructions. And so we have the idea of reuse to make sure we don't repeat the same mistakes that we did earlier. So it is a FMEA with all the failures counted in and the best controls throughout the company. So the reuse of process elements. And of course, what does the structure analysis lead to? The function analysis and the failure analysis. We'll tell you more. All right. As I move away from the slide, I'll just say this. Well, that the middle is really the process steps, the structure. You can say the left-hand side of the structure is the entire line, and then we have on the right-hand side the
Functional requirements.
The work elements, or the 4M, we'll say, okay? So here is the process flow that we see as that the handbook says is a good input. Well, you'll see an Omnex suggestion in the very end of this webinar on how the process flow can be used in the 6-step process. And of course, product characteristics and then process characteristics. This is sort of what Omnex has always taught as a best-in-class approach to manufacturing process flows. And so you see then the XJ770 line. In the middle, you see then, remember it's a 3-level structure in the PFMEA. Whereas in the DFMEA, you went as long as the BOM is in terms of system, subsystem, sub-subsystem components. Here you see the line on the very end, the steps in the middle, and the 4M on the right-hand side. More about that in a little bit. Okay, another example of that. Okay, now so we'll just show this. All right. We'll just show you this in the running example that we have. We have done the 5 T's, and here we're going to do the structure and the XJ770. And folks, if you've already entered it in, or if you have it by the process family, let me just go backwards here a little bit, pause it. If you already have, if it's under a family, soon as you pick the line under the existing line, you'll immediately inherit, as we call, these steps, right? And then you can add operation here, as you see, and then you can add operations. And then when you click the, let's see if I can get my laser pointer here. If you click this, which actually says 4M, you can add the suppliers tool setup. And let me escape out of here. Maybe I'll also zoom in so you can see it a little better. All right. So you're getting the idea of the structure analysis. Very straightforward, folks. Think of it as nothing more than a little bit more than the process flow diagram. In fact, if you're using software, when you do a process flow diagram, you can get most of the structure analysis done. All right, I will stop there, and then we'll move on. So what have we done so far? We did the 5 T's, and we also did the structure. Now you have to do the function analysis. So, Greg?
One of the unique things about the handbook is that you need to identify the functions and requirements not only at the focus level, which is indicated by the second level, the steps themselves, but you also have to do it for the whole process. So the whole process is, the requirements are really the requirements of the product. It could be the process results, health and safety, or logistics. The reason why you're doing specific things in the process step itself. These would become, or will be, when we look at the failure analysis, the effects of a failure mode at the second level. Now, in the third level, the influencing factors, the work elements, the 4Ms. We have those 4Ms, and now we have to define what are the expectations, what are the functions, or really, at this point, we're really talking about what are the activities that are going to be done. The operator does something, the machine has to do something. So these are the tasks, and here's where we introduce the process characteristics in there. So the product characteristics are in level 2, then the process characteristics are from level 3. And the level 3 failure modes are candidates for causes.
Thank you, Greg. So, let's look at this. Really, when you look at this example, the function analysis is what is the function of the overall assembly line that assembles the airbag is to assemble airbag. What is the function? So really, when you get to the process, we don't really focus so much on functions. It's really the requirements. And the requirements are nothing but your product characteristics. So if you go to your in-process print, just like before, you identify the in-process characteristics, or if it's got final characteristics, fine. You list the characteristics that the soldering process does, and then you identify the 4M on the other side. In this example, we show you the machine and the speed of soldering. Now, we could overpopulate the right-hand side, just like we used to do before, where we would do brainstorming. You could end up with millions of work elements, but really we shouldn't. We should look at our history and our understanding of this process, think of it subsequently as being a cause-effect relationship with the failure mode. So populate, we say, the work element with the most likely failures.
Yeah, dominant source of variation.
Dominant source of variation. Exactly. All right. Now let's continue with our example. Let's look at the function analysis. And we're again the same product. We have done the structure analysis. So we see, let me just pause it here. So initially what we're seeing is let me just zoom in so you can see. All right, let me zoom in so you can see this. So we're looking at the operation 20 cold form. Left-hand side is the line that we haven't written the functions for. And the right-hand side, from the structure analysis, we say supplier, tool, and setup are the most prominent sources of variation that affects this process. So let's continue here. So we identify, let me just zoom it forward a little bit, and we're entering in, and you don't have to do it in every line. We just have to enter it in one place. Here we wrote down the function as transforming this bar to customer specifications of XJ770. And on the cold form, we identify the characteristics that the cold form works for. And then let's continue. And we enter in, we're still populating the XJ770 on the left-hand side. Now we focus on the right-hand side with a supplier. Let me just zoom forward here a little bit. And see if we can see that a little better. Okay, the functions are supplier, tool, and setup. Really, when we finish step 3, we have then scoped it, done the structure analysis, and done the function analysis. Let's go to the next step. The next step is taking that function analysis and coming up with a failure analysis that goes with it. So what is the purpose of the failure analysis? Really, once we have, let's say with the process step, we have the requirements, it's a negation of those requirements, right? The characteristics. If it's an inside diameter, it's oversized, undersized, and so on. So, and then of course, there's a there's a failure in the middle, a cause on the right-hand side, and an effect on the left-hand side. And the failure analysis introduces that relationship, and in the AIAG VDA thinking of things, each of them is a failure of the function/requirement in each of the structures. Okay?
Yes. As it turns out, when you're doing this, is really two sub-steps, if you will. One is identifying the failure modes of all the functional requirements, and at that time we just look at the functional requirement and says, what is the failure mode? We don't talk about linkages or anything. Once we got our lists of failure modes for the higher level, focused, and lower level, then we do the effect failure cause relationship so that we put them together. So we said this failure mode would cause this effect and is due to this cause.
So let me just also comment on this, Greg, especially because we'll have a picture later on how. So the idea is, and by the way, this has always been part of the Omnex methodology, is the linkage of the process failure to the design failure. Especially if you have, both the DFMEA and the PFMEA, and you have a database behind it, you can just, have a drop down and pick the design failure that goes with the process failure. More on that, because a lot of people get a little concerned in terms of, as we explained the DFMEA, when we did the AIAG VDA DFMEA, we mentioned in the components, the third level structure is always characteristics. And the characteristics there are in terms of looking at the same characteristics, but looking at the design failure of the characteristics, we're looking at the same characteristics now, but looking at the process failures of those characteristics. I'm sure I confused some of you, but bear with us. It's something you're going to have to get used to and learn. All right. So, yeah.
Following up on that, the writers of the handbook do realize that they do have to consider the design activities. So a lot of times when you're looking, especially if you're looking at a component or a part, the higher level may not be actually directly used or interfaced with the end user, the vehicle driver. So you notice that under column 1, it said the in-plant, ship-to-plant process item, and vehicle end user when known. So you have to go really in a step beyond the higher level in order to say, well, how does this failure mode affect the vehicle end user?
And at the end of the day, if you have, all your multiple design FMEAs, system FMEA, and so on, and you have the process FMEAs, you can daisy chain up, and you can pick the highest severity item automatically, especially if there's software being used. Okay, but there's a daisy chain there. All right, so we have the failure mode of the process step in the middle, the failure effect on the left-hand side. Folks, it's the same effect of failure that you're used to. All right, and on the right-hand side, the failure cause. Now, let me, one of our key consultants, Dave Watkins, who does a lot of workshops, what he mentioned in this, he said, look, what he likes about this methodology is the specificity of the cause. And I'm trying to think, let me just give an example. A lot of times, and especially comparing these methodologies, we've been doing a deep dive into the AIAG 4th edition PFMEAs, and people have things like poor setup. Is poor setup a good cause? Well, that's what they have. But now what you can do is, when you're thinking about the failure of so it can become more specific in what in that setup is the cause of the failure mode.
Right. When you're coming up with the function of that work element, the function of the activity of setup for the operator. Well, operator is the work element, and then we're supposed to have the setup. That's the function, but we also need the requirement. What is a good setup? And therefore, when we come to the failure mode, which would be then the failure cause of the work, or failure mode of the work element, we define what is not a good setup, rather than just use the generic term for setup.
So there's a lot for us to discuss yet, because, I have some difficulties, Greg, I'll just say this. When you do the function analysis, I don't want to verbalize everything there. I'd rather just have a hyperlink to my setup instructions. Work instructions. So while I was talking this over with some of our key consultants in the German office, because we're doing this collaboratively, and I don't know, as we speak, we're writing a couple of articles also for the key German magazine in terms of the AIAG VDA FMEA. And, her response was, what if it's a new product? Well, I said, look, in our company, I'm just saying any company, typically we're always making another product in the same product family. So as soon as you pick a product in the product family, you can immediately get all the hyperlinked work instructions or setup instructions, your operator instructions, your PM checklist, all of which, if you want to say, could be on the work element level. Anyway, more on that later as we go along. So what are we doing here? We're doing the failure analysis, linking the failure mode of a characteristic with a failure effect and a failure cause. So so we have created this relationship already. So I'll just zoom in. This is what we did in the last step. So what we're doing here now is we're going to come up, and you'll see it in red here, the failure modes. So again, the failure analysis, we're picking the cold form. And immediately, let me just pause it there. I'm a little slow. You can see here, Omnex always likes to have a PCID, and of course it's coming from DCP. The characteristic, and you can either identify, you can put the failure here, and it'll refresh automatically in the bottom. Okay. Here, let's continue. I'm just jumping ahead a little bit, and we put also the effect. So now the failure mode, the failure effect, and the failure cause are going to get linked in to what is called the failure net. Okay, so we're adding the causes now. We zoom forward a little bit and zoom in so you can just sort of get to see what it looks like. Okay, so the same structure, and we see then, and of course, the way it has to be is you should be able to see it all, or see the lines one by one by sorting that in case there's some confusion to it. All right. So this then is the most important step so far. Every step is important, but the failure net, and you have to do that for each of the characteristics, and we would say all the characteristics. Well, I did want to make this point here. Let me make this point before I go on. One of the effects is, let's say the body OD, let me go to the very end here, just to talk about that. If the diameter exceeds the upper spec limit, it's not only going to cause an effect here in terms of locating and clamping in a subsequent setup as we have an effect, it also causes a design failure. All right. And so one of the effects you could pick here from the DFMEA, when you right click, is you can pick all the design failures and link the process failure to a design failure. Okay. Now to explain that, this is the best way to see that, where we see the piston assembly does not transmit force is a failure for the design. Folks, so we're looking at this DFMEA for the component, and the point I want to make, Greg, and you can just jump in anytime you want, is that the same failure, design failure, and folks, some people get all bent out of shape. Hey, a process failure should not be brought into the design FMEA, and you're absolutely right. This failure is a design failure in terms of speccing out the part, okay? The same characteristic has a process failure in terms of, wrong cutting tools being used, and it affects. The effect of it is a design failure. Greg, any other comments you want to make on this?
No, it is the cascading. You're going from the system to the subsystem, and eventually you get down to a part level, which is what that is, and then the part level, you eventually get down to the process.
I'm sure some of you, we got lots of questions in the last webinar we did about the DFMEA. Can I do a DFMEA on my component? And the answer is, of course, if you have the component, you have the higher level, on the left-hand side is your customer, on the right-hand side are actually characteristics, okay, in the design FMEA for component. So, and again, you're only looking at design failures, and let me just stop there and not over-explain. So when we were in the last webinar, we went from the system, subsystem, and component. Now we're going from the subsystem component to PFMEA. I will just mention this. There is a big absence, Greg, of people talking about the process failures for a subsystem or a component. And of course, there's an assembly line making the subsystem and the system. If we showed you all the process FMEAs, would confuse you. For whatever reason, we're seeing it's being left out. But more on that later in our third webinar. Let's continue. Folks, I'm going to pause here because we haven't paused before in terms of making sure you have a chance to write down questions you may have. And we do see a number of questions. And folks, we'll do our best. We had 40, 50 questions last time, and we see that many questions here again. But go ahead and ask your questions. We'll do our best to address it. All right, folks, let's continue. We see a lot of good questions, and we're happy to answer this. I just wish that, there's another interface where somebody who's asked a question that we already answer can go back and say, I don't really want to have that question answered anymore. But that's life. All right. So let's go on then. Step number 5. So we have 2 steps left, step 5 and step 6. Step 5 is, now that we have got the failure analysis done, we're going to do the risk analysis. Folks, I am just going to escape out of here and go back into presentation mode, because I did look at some of the questions, and there was a question asked about, so I've got this as big as I can do it in terms of presentation mode. Okay, so just to answer a question somebody had.
You may be able to, through your web
interface
to expand it to full screen. If you go up on top and you do it on I think it's a small screen, it will allow you to go to full screen presentation mode. But that's on your side. We have no control over it.
Okay. All right, so we'll go on to step 5. Step 5, the purpose of step 5, of course, is to assign preventive controls and detective controls. Remember, the preventive controls are all part of occurrence, and the detective controls are to do with, of course, your things that you will do in your control plan, as you call current controls. And then, of course, you have to go back and rate the severity, occurrence, and detection for each failure. All right. So this is where we finished in the last step. And what you'll see when we do continue this example is there will be a form like this that gets filled in for corrective prevention control. And the prevention control always has to do with the failure cause. And the detection control, of course, is detecting the failure cause or the failure mode. And then you'll have to go back and put in the severity, occurrence, and detection numbers, okay? Again, it'll be a little small when I show you the example that we have in software, but I will pause and I will zoom in just so that you're able to see that. Now, there's two ways to put this in. One, you can do it right here, or you can actually do it in the form itself. I think, especially in the PFMEA, the form works very well. So you can see here, let me just pause and zoom in so you can see. Okay, so they're putting in the prevention control, and it's based on the failure net that you have picked. All right, continue here. So the detective controls, now we're working on the second one, and you can see that industriously they're filling in. Let me just stop right before they go into the form. Sorry about that. All right. So when you fill that in, even before that, you can go right to the form, and you can see in the form here that automatically, the software calculates the AP or the action priority, and it says it's a low risk. Or you may have one with a high risk that they have identified in terms of recommended action. And in this example, they just went ahead and actually filled it in and showed it as actions taken, along with the action priority that brought it back to a green status. All right. So really, step 5 and step 6. Greg, any comments you wanted to make on the previous step, actually?
No.
Yeah.
Again, you can either do it in the example, either through the software and develop the lists and then show it in the form, or you could bring up the form and actually type it in the form itself, and then the lists will be updated from the form.
All right, so a couple of things we want to talk about now is we just picked a few. Again, you can see we knew it would go right to the end of the hour, and we had to pick and choose what slides we could talk about, and we want to talk about slides that show differences in the methodologies. All right, here, of course, there isn't much to say. This is the very same. You have to enter the ranking on the left-hand side. It's for the most severe effect, okay, that you have to put it in, and that's what goes into the column. That's why if you don't link it back to all the different process steps to the left-hand side or all the design steps, you may not get the highest severity. Keep that in mind. So, Greg, I'll have you do the honors of talking about the difference between the 4th edition and the AIAG VDA FMEA.
Well, the severity of the effect is very similar between the two. The most dramatic change, if you will, is that in the 4th edition, the 9 and 10 is hazardous situations or regulatory violations with and without warning. In the handbook, they have clearly split that up. 10 is hazardous, safety-related. 9 is violations of regulation. Whether you have warning or not is irrelevant with respect to that. That's probably the most dramatic one of the for security.
Let's go on. Go ahead.
All right, Greg. This is the occurrence. In the occurrence, the estimated occurrence doesn't really provide a whole lot of direction. They use the words high, very high, moderate, but they do include two other columns, the process experience and the preventive control. So when you identify the preventive control column, you have to evaluate or can use that to evaluate the occurrence. And so you would do it based upon process experience and preventive control, and then it would be the highest or the lowest occurrence of the two. You can also add in a corporate or product line examples that are hopefully consistent with the rest of the table. This was actually available in the 4th edition, except they didn't actually put a separate column. They just said that you can modify the tables based upon your needs or experience.
Folks, as we're getting better and better and better, especially for the customers that we're working with are in parts per billion, really, you need to really tighten up your estimated occurrence. And especially if you have the data for your failures, automatically, actually, people like ourselves will give you the occurrence number in your table for that product, and you can use it for estimation. In fact, we'll do a webinar, a very interesting project we're doing right now, Greg, with a customer who's using Aqua Pro, and we have all that data, and we're going back and populating, in terms of estimation, both PPMs inside the plant, inside the company, external, and I thought there was one other one, I forget exactly, all 3 PPMs. And it's a good way to really then figure out what your occurrence should be.
All right, and again, as Chad said, we're only taking selected slides here. We're not giving you the entire table. We're just trying to point out some of the differences on there. In detection, it does follow the general flow of the 4th edition. However, it does have, I need the laser.
Yeah, I'll get you the laser.
All right, it does put in more detail. As you notice, this is much bigger on that. And it also puts in conditions. In this case, the ability, the test inspection method has not been proven for this. The company or business unit has experience with the defined there, and so that would be a 6. A 5, however, says test and measuring equipment for comparable process has been confirmed through gauge R&R evaluations. So that's a additional detail with respect to that. The beginning is pretty much the same, as well as the end. This would be first piece or last piece checks for setup controls, setup causes only, and that is consistent with the 4th edition on that.
Let's go on to the next one that we wanted to make a comment on. Sorry. Just the idea that based on severity, occurrence, and detection numbers, we have to pick action priorities, all right? What you're seeing here is a guidance or recommendation from the handbook, and with the caveat, you're always free to fine-tune it for your own organization. Now, some differences here, if you know, this is not strictly the case. The 4th edition used RPN, but many of our customers also had rules of severity, occurrence, SO, and SOD. And the action priority table does give us, go ahead, Greg, you have done some deep dives in terms of and some of the conclusions here in the next few slides are things that Greg has seen.
Well, what it did is tries to come up with a logical detail for all 1,000 possible combinations, 10 times 10 times 10 on that. So when they come up with it, it's supposed to work. You still have to do severity, occurrence, detection, and then you go into the tables to determine whether it's a high, medium, or low. Again, there is the recommendation, as was in the 4th edition, that if you have a severity of 9 or 10, you do it regardless of whatever the other result is. In there, they said that an action priority of 9 or 10, high or medium, at a minimum be reviewed by management, including any recommended actions that were taken. Now, within the normal APQP, you would have design reviews, and you would do a review of the PFMEA and that, but this is putting explicit recommendations on.
Hang on, Greg. One thing I wanted to mention is when we taught the PFMEA and the DFMEA, we said, look, work on all severities, 9s and 10s, okay? Now, when you look at these tables, you'll see there are some 9s and 10s which are medium, some 9s and 10s which are actually also low. So a difference that I want to point out.
Yeah, but it does also say potential 9s and 10s failures. Well, it said high and medium. Right.
Yeah, go ahead and mention the shall and the should.
Okay, yeah, they have defined in these tables, and you say, well, what's the difference between a high, medium, and low? And the key on here is the high is the must. You must identify appropriate action or justify and document why the current controls are adequate. So you've got to go through every one of the highs. In the medium, it's more of a should. The should is taking the standards terminology. It's something that is recommended, but if you don't do it, it's not mandatory. And again, justify and document why controls are not adequate. And in low, it's a could, which is lower than the should on that.
Thank you, Greg.
All right, so this is an example of the PFMEA table where you have the lows, mediums, and highs. Now, notice that in the PFMEA, they do have column where the occurrence of 1 has everything that's error except for a severity of 1. The reason is that if you have a occurrence of 1, the only way you can get occurrence of 1 if you have preventive controls of error proofing. You have the controls where you cannot produce a bad part. In that case, then the only detective value that is allowed with that is a 1. So a D of O of 1 requires a D of 1. And so if you have a occurrence of 1, you'd have a detection of 1.
Hence the error state.
Hence the error state.
Okay.
As we go through, we're not going to go through them all, but you notice that the green starts propagating, the M's start propagating, and when we have a D of 2, we get a lot of green and a lot of M's.
And the point in the last 2 slides, you saw 9s and 10s being M and also now L. Shall I continue?
Yeah, you're talking about severity.
Yes.
All right. Now, there is a concern of that if you wanted to equate it with RPN. For example, if you had an RPN of 56, it's identified both as a high as well as a moderate. And if you had even an RPN of 32, that could be both a low as well as a high. So in this particular case where you had an RPN of 60, you see it can be either a high, medium, or moderate, and a low. And so when you are using these tables, you are kind of not really equating it with RPNs because how do you do that? So you would have 3 of them. What do you do on that? 1 you must, 1 you should, and 1 you could.
And you could really say you're throwing out the RPN strategy completely out the door.
Right.
Right. So, folks, how do you understand severity, occurrence, and detection? Severity is, of course, the severity of the risk. all right? Severity times occurrence is really, classical risk is defined as occurrence times the potential of the failure, okay? Severity times occurrence. So without the controls, SO is the risk. SOD, RPN, is always the residual risk, right? That's the classical understanding of all three.
Yeah, but one of the things you can see for a given detective value, all those in the red are all high. All of them have to be acted upon. But what is the priority that you're going to be acting upon? If you have a 60 or you have a 320, I would think you would want to work on the 320 or 360 before you work on the 60 from a priority standpoint.
Exactly. All right, folks, so here is then the 6 steps that we walked you through, the 5 T's that go with the scope, the structure analysis with the process step in the middle, the line on the left-hand side, and the work element of 4M on the right-hand side. The function analysis with the function of the line, function in the middle is actually characteristics, and the right-hand side is the most correlating 4Ms. Then there's a failure analysis, a negation, starting from the middle where we identify the failure mode of the characteristic, and then you go on the left-hand side and ask what is the effect of it. Then you go to the right-hand side, what is the cause of it? And it's seen in the methodology as a failure of the process requirement, a failure of the 4M work element as a cause, and the effect being a failure in the line. Then, of course, we came back, put the detective and preventive controls in, and we identified SOD, and then based on the AP rules, optimization. All right. One last thought from Omnex before we conclude the webinar and take your questions. One of the things we would like to propose is that both step 2 and 3 be done using a process flow diagram. If you look at the US methodology, always we said process flow, PFMEA, control plan, work instructions, right? So if you can just say the handbook leaves out very much the control plan and leaves out what we call the failure-based work instructions or standardization that needs to take place in the line. At the end of the day, all the work we do goes to naught unless we actually implement it on the shop floor. Anyway, the idea of doing the 6 steps using a US tool, the process flow, to do the structure and the function analysis. Greg, any thoughts on that before we?
No, we can go to the next
all right.
one. Right.
So folks, let's pause here. This is what we talked to you about. What goes into the PFMEA, AIAG VDA FMEA format, and our thoughts on it.
Yeah, one final comment on this, and I would assume that this will be fixed up in the final release, is that the APQP, and I believe it's even in the IATF that says that significant characteristics have to be identified on the print. They have to be identified on the process flow, process FEMA, process control plan, and work instruction. We don't have a column for significant characteristics. So I don't know how they're going to work that into the form
That's a big
itself.
miss. That is a big miss.
Yeah.
All right. So with that said, folks, let me pause here for a couple of 30 seconds. 30 seconds, it'll go quiet, but we're going to continue. What we'll do when we come back after 30 seconds, and a 30-second pause is so you can write questions, we will conclude the webinar with our key thoughts, and then we'll take Q&A. So let me pause here. All right, everybody, let's continue. So what do we have to say as concluding remarks? Currently, the new AIAG VDA FMEA is in draft stage for a 90-day commenting period. Now, first release, I don't know why we say that when we know it's not the case. So it will be somewhere, let's say May, June, July. the new FMEA, of course, the big deal though, as we say it, Greg, is that the AIAG VDA team is not the SQRT, the Supplier Quality Task Force put together by the OEMs.
Right.
Hence, there is a process there to be followed. Let's continue. The new FMEA has adopted a 6-step process for both the DFMEA and the PFMEA. The DFMEA has been the most profoundly affected document in our estimation, where I think where the most learning will take place. The structure analysis and function analysis impact is much weaker in the PFMEA. Hence, we suggest a US tool, the process flow diagram. And folks, what we should not lose when we adopt new methods is all the success we've been riding on from the past, which is that we have always done all the process steps and all the characteristics. The AIAG VDA FMEA handbook recommends use of FEMA software. As you can understand, if you want to make all these linkages, that will help. And this FEMA methodology, when released, will not be applicable until the IATF 16949 deadline. So I'll just say this again, because it's a question where we're not going to answer that somebody asked. This methodology will not be applicable till the end of the year when the IATF 16949 deadline has passed. With that said, go ahead, Greg. Let's take on some questions. Read out the question, and then we'll give up.
Yeah, there's a question about the equipment or machine FMEA on is it required or recommended. All the blue books, except for PPAP, are recommended. They become required only as CSRs. There are the machinery FMEA does have some customers that are requiring it, but you need, for example, I do know that GM Powertrain is requiring it, and a couple of others.
So we've actually done it for a few OEMs. Greg was also on the writing committee for that, but let's go past.
Yeah, I'm really just saying is that they need to define, talk to their customer on that.
Yes.
This other one I searched yesterday for a draft AIG site under the publication store, could not find it. I guess because it's the end of the 90 days, they pulled it. But I don't know.
Folks, we're not able to give you a copy because, you know, we don't want to violate any ethical rules. It was only available by, what do you call it? Interface.
With the AIG, right.
Some of you may have figured out interesting ways to get copies made, and maybe we can share it with you. Okay. What are the 5 T's? The 5 T's are scoping, and each of that's timing, team, and so on. So there's 5 T's, and you fill that out as a scoping suggestion as a scoping step. When you say that we can at least have 3 levels, what is required number of levels? Well, you really can do the AIAG VDA method without 3 levels, right? There are more than 3 levels in the DFMEA. In the PFMEA, there's always only 3 levels, yes, which is the process step in the middle, the line on the left, and the 4M or work element on the right-hand side.
Okay, related to that, we have a question in slide 36. The potential effect of piston assembly does not transmit force, does not seem to have an effect noticeable by the customer. Should effect be brake system? This is the whole thing of the cascading effects. The higher level that you're producing is the piston itself. The piston has, if the piston itself does not successfully satisfy the requirements, then eventually it is the top. And so in the PFMEA, we do have or vehicle user. So you could put that in the effects column, but the higher level failure mode, which is what we were trying to show the cascading, effect would be dealing with the physical piston itself.
Folks, comment, this is huge work. Are we supposed to convert all our FMEAs to this new standard or just for new projects? How long can we have both standards in our FMEAs? Again, the answer is we'll have to wait and see what we hear by the end of the year. Right now, it's not absolutely clear what is going to be required. Okay? So
they also say that you can grandfather, if you have existing FMEAs, you do not have to convert it to the handbook approach. They would look at you using the handbook approach for new FMEAs that you are developing or new processes that you're developing.
Folks, many questions on the software. Yes, it is a software that Omnex sells. It's part of our enterprise-wide quality management and integrated management suite. It's called Aqua Pro. It's been around since the mid-1980s. We're very proud to say is the first package out there to help companies do this. Greg, there's a number of different questions that have just recently come in. So I won't answer any more questions on the software. Just to tell you, it's my life's work, so it is something very near and dear to my heart. When would companies be required to actually change to a new format? I think we answered that. Can I get a copy of the presentation? Absolutely. You can get a copy of this presentation. When can we obtain a revised draft edition of the document? It'll probably be June, July, Elizabeth. A couple of different questions on the same topic, June, July, before you get a final version. You want to answer this from Scott? In your comment on assignment of severity, you suggested using the highest rating. However, the new process suggests multiple assessments for a given cause based on impact to the vehicle. I mean, I think he says there's a multiple different severities.
But you still pick the highest one.
You pick the highest one. Because it's the same failure, Scott. And that is not anything new.
No,
it's been around. Maybe what we didn't see very clearly is the idea that a process failure is linked to a design failure. Okay. So we have a question from Giovanni. Dears, with regard to the last tables that comprise severity, risk, occurrence, and detection, can you kindly provide a practical example in order to deepen the interpretation of the numbers circled? Not quite sure what he means, but I think you think it might be with the RPN So Giovanni, if it is what you're asking, the same RPN numbers, because the AP or action priority is governed by S, O, and D. When you look at if you look at it from a residual risk viewpoint, which is RPN, you find the same RPN number, and we gave an example where 60 is the same 60 RPN is rated a high, a medium, and a low.
And all of them have the same base SO value, severity times occurrence on that. So within the same SO, the same base risk, you could have it be high, medium, or low, depending upon where it is.
So, with that said,
well, one additional point. It says in your DFMEA, where do you identify product characteristics? You don't identify product characteristics in the DFMEA. You identify functions.
So what we have done, I'll just say this: in functions, a product. I didn't say this. Lawrence D. Miles, who came up with value engineering, defined that a product is made up of functions. All right. So a function is a verb noun, an action verb with a noun, and you define, it's actually 5 to 8 functions will define every product. There's also primary functions and secondary functions. So a product is made up of functions. Functions have requirements. Requirements have characteristics. So in the initial design, you identify functions and you identify requirements. And of course, linked to it is characteristics. So what we actually do is, again, you can only do it really if you have software. We actually do a right click and attach the characteristics right to the requirement. But you end up having to do that anyhow to understand the relationship between characteristics and then failures in the design. All right. So with that said, folks, thank you very much. We enjoyed doing this. And again, apologies. We had a ISP provider blip as we were trying to start the webinar yesterday. We're very happy. Everything worked out well. Thank you very much. We will have a third webinar where we want that to be a higher level webinar. We're going to take what we have talked about in the first two webinars and talk to people who have attended both webinars as our critical analysis of the AIAG VDA FMEA. So look forward to talking to all of you again, either in our next webinar or all the other different webinars we try to hold time to time to help our customers. Folks, thank you very much. Thank you on behalf of Greg Gruska and myself, Chad Keimel. Thank you all. Bye-bye now.
Bye-bye.